Hey, it's Mr. Allred, and we are working on exponential and logarithmic equations, and we got some practice problems here. The first one here is the natural log of 15x minus the natural log of 3, and that's all equal to 6. So both of these are natural logs, so that means they're both base e. But if you think about it, if you tried to rewrite this in exponential form, you've got two different arguments here, one 15x and one of them 3, so it wouldn't work out very well to have the two different logs here to start with. A couple of ways you can handle that, but the best probably is to notice the subtraction between them and use the property of logs that says if I subtract two logarithms, I can combine them into one logarithm with a division. So that left-hand side will turn into the natural log of 15x over 3. And that'll be equal to 6. And now I can rewrite it as an exponential. Base e to the 6 equals, and then I'll reduce that inside part to 5x. And if I want an exact answer, I can divide both sides by 5. So e to the 6 divided by 5 is an exact answer. And let's see what the calculator says about that as far as a decimal approximation. Okay, keeping 4 decimal places, I've got 80.6858. Okay. The second problem over here is log of x minus 2 plus log of x plus 2 equals 2. So once again, multiple logs in here. It'd be nice if we were down to just one log. We'll notice that they're both the same base 10. So I'll go ahead and use that same rule that says if I'm going to add two logs together, I can multiply their arguments. So x minus 2 times x plus 2 is a FOIL, but it gives me x squared minus 4. And that'll all be equal to 2. So I'm going to go ahead and convert this to exponential to get that argument outside. So the base is 10 squared equals x squared minus 4. I know 10 squared is 100. I'm going to move the 4 over. So I'm at a point where x squared equals 104. Now if we go back to how we solve quadratics, we can look at that and we can say, well, that should give me the positive and negative root of 104. So that's how the quadratic solves. Let's see what those look like written out. So we'll go to the calculator. Square root of 104 is 10.198. And then we also get a negative version of that. Negative 10.198. And something we may or may not have discussed about logarithms is your answer has to produce a positive argument inside the logarithm. So way back up here at the beginning, whatever I plug in for x must make x minus 2 positive, must make x plus 2 positive. So it's not a problem to have two answers, and it's not a problem to have a negative answer. It is a problem if you plug one of these answers in and that argument becomes negative, because basically you're saying 10 to some power would give you a negative. But no matter how many times you multiply 10 by itself, or divide 10 by itself, it's going to stay a positive number. So let's just see. If we estimate our answer as 10, 10 minus 2 is 8, which is positive. 10 plus 2 is 12, which is positive. So that one works out. The negative 10 minus 2 would be negative 12. So that automatically rules this one out. Okay, let me make sure that negative still looks like it's there. Okay, so we only get one answer out of this. Okay. All right, so be very careful when you get an answer. Kind of look back and see if it works. So if we went back to the first one here, the 80 times the 15 definitely gives us a positive number. It's not a problem.